Hello my dear students, this is Physics Balaji. Today let us discuss JEE Mains 2026 question paper conducted on 21st January evening shift. In previous 3 videos, we have completed 1 to 15 questions. In this video, we are doing 60 to 20 questions. Question number 16. Here 2 cars are moving parallel to each other with the velocity shown. Initial separation between the cars is given 10 meters. Find angular momentum of car A with respect to car B. This belongs to rotatory motion concept. So in rotatory motion here asked to find angular momentum. So you are asked to find angular momentum of car A with respect to B. Angular momentum formula, so momentum of A with respect to B into perpendicular distance. So here car A velocity was given 36 km per hour. Convert into meter per second. 36 into 5 by 18, you will get 10 meter per second. Even car B velocity also meter per second. So 72 into 5 by 18 meter per second. You will get 20 meter per second. Momentum is mass into velocity of A with respect to B into perpendicular distance. Mass of car A, M only, VAB formula, velocity of A minus velocity of B into perpendicular distance. Mass of car A, velocity of A we got 10, velocity of car B 20, perpendicular distance between these two, velocity of A with respect to B, this distance is nothing but 10 meters. So perpendicular distance is 10 meters. Simplify this one, will get minus 100 m. You are asked to find magnitude of angular momentum of A with respect to B. You will get 100 m. Option 1. Let's go to next question. This question belongs to LC oscillator. So in LC oscillator, initially at time 0, charge of the capacitor is given maximum. Now at time t, charge becomes. So in LC oscillator, charge varies simple harmonically. So simple harmonic equation will be like this. Q equal to Q naught cos omega t. Because at time 0, charge should be maximum. We should take cos function. Now, charge becomes 25% of initial value. So charge is 25% of initial value equal to Q naught cos omega t. So here you can see Q naught gets cancelled. So 1 by 4 equal to cos of omega. Resonance frequency of LC oscillator omega equal to 1 by root LC. So omega value we know 1 by root LC into time t. You are asked to find time value. So bring that cos this side. This becomes cos inverse 1 by 4. Bring that root LC this side. This becomes root LC equal to time t. Option 1. Let's go to next question. This question belongs to a river boat problems in kinematics. A boat crosses a river 200 meters wide in a minimum possible time, shortest time case. River velocity given 5 meter per second. Velocity of boat in still water is given 10 meter per second. Find time taken to cross the river and displacement of the boat he was asking. So, in shortest time, so we should row the boat normal to the river flow, velocity of boat with respect to still water. So it is the width of the river. So time taken to cross the river in shortest time formula will be d by VBW. So width of the river given 200 meters, VBW value given 10. So you'll get t value 20 seconds. Now they're asked to find displacement of the boat. It was the initial position of the boat. Finally, the boat will be drifted to this position. So this is nothing but called drift. So we can find drift value. Drift means horizontal distance. Distance formula velocity in time. So in this direction, water velocity will be VW into time t. Water velocity is 5 into time we got 20. This is 100 meters. So this drift distance we know 100 meters. From this right angle triangle, this is 100 and this is 200. Then this hypotenuse I want. So this becomes root of, displacement becomes root of 200 square plus 100 square. So now finally displacement will be equal to root of 200 square, 4 into 10 power 4, 100 square, 10 power 4. Simplify this one, you will get 100 root 5 meters. First option. Let's go to next question. This question belongs to again rotatory motion. In this it is given, in a diagram shown below, pulley is of ring of mass m and radius r, fitted with two rods each of mass m. Here one rod, each of mass small m, it is another rod. Each length 2r, that means this rod is kept diametral to the pulley, such that pulley rotates. Rod also rotates with the same angular frequency. Find the magnitude of acceleration of m when system is released. If we assume capital M is heavier than small m, so this will come down, it will goes up. Now let us take free body diagram of capital M. Capital Mg downwards. Here tension is some T1. Here for small m, so free body diagram, small mg downwards, here tension will be T2. Here I have taken different tensions, reason it is a massive pulley, so tensions in the strings will be different. For every action, here reaction also will be T1 only. For every action, reaction also will be T2 only. For free body diagram of M, you can write, so this body will come down with some acceleration, it will go up with an acceleration A. Now, free body diagram of capital M mass. So acceleration will be equal to same direction of acceleration plus capital Mg, T1 opposite, so minus T1 by M. Let it be equation number 1. Similarly, free body diagram of small m. So there also acceleration will be equal to formula. Same direction of acceleration is plus T2, opposite to acceleration minus small mg by small m. It is equation number 2. Now let us apply free body diagram for pulley. On this pulley we will have torque will be there. Torque formula force into Papan distance. This T1 into Papan distance will give anti-clockwise torque. T2 into Papan distance will give clockwise torque. But finally this wheel rotates in anti-clockwise as we assumed M is heavy mass. So due to that, so T1R is greater than T2R. So tau equal to formula we know I alpha, where I is the moment of inertia. So moment of inertia was mr square by 2 plus rod moment of inertia is ml square by 12. Mass of the rod small m. Here length of the rod is given 2r. So ml square by 12 into 2 rods are there finally. It is total I value into alpha equal to, so T1 minus T2 into R. Let be equation number 3. Take one more equation for a pulley acceleration A equal to formula R alpha. So it is equation number 4. Here T1 unknown, T2 unknown, A unknown, alpha unknown. 4 unknowns, 4 equations. You can solve them to get magnitude of A. So you will get first option. Next question. This question belongs to dual nature, de Broglie concept. A mass, charge and potential applied across a particle is given. Mass given, charge given, applied voltage also given. You are asked to find de Broglie wavelength. De Broglie wavelength formula lambda equal to h by mv. H by momentum formula can be written as root of 2mk. Again kinetic energy can be written as root of vq. So here mass of the particle is given, potential difference given, charge of the particle is given, h value we know, you can find lambda value. You'll get answer 9.4 into 10 power minus 12 meters.